Here in our next lesson, we're going to learn how to combine integers. In the last lesson, you learned what an integer was, and now in today's lesson and the lesson that follows, we're going to learn how to manipulate them, how to apply the order of operations to integers. Before we get started with our 4 examples, we're going to go over our 2 vocabulary terms. And they're actually quite similar. Our first term, additive inverse. The additive inverse of a number is the opposite of a number. And our second vocabulary term is opposite. This we had in our previous lesson. Numbers that have the same absolute value but different signs are opposites. Now before we get to our first example, I just want to go back to our first vocab word, additive inverse. Basically what it means is when you have a number and you add it to itself, their sum is 0. Let's get started. Before we get started with our examples, we're going to go over some rules for combining integers. Let's take a look. When both integers are positive, 2 things happen. 1, the answer is positive, and 2, you need to add the 2 numbers. So for instance, here we have a positive 5 and a positive 8, and together they make a positive 13. Let's look at the second rule. When both integers are negative, the answer is negative, and again, you add the 2 numbers. So if you look at this example on the side, we have a negative 9 and a negative 12, and together those 2 negative terms make a negative 21. So you can see we are moving away from saying things like 5 plus 8 or negative 9 minus 12. And the reason for that is that I want for you to start recognizing each term in the expression or the equation. And next we have, when the integers have different signs. The first thing you're going to do is write the sign of the greater looking number. And I put looking in parentheses because if you look at our example, we have a 6 and a negative 84. Well, by virtue of the fact that the 6 is positive, we know that that number has a greater value. But when I say greater looking, it means here 84 looks like it's bigger than 6. Since 84 is a negative number, our answer has to be negative. And then after you write down the sign, you subtract the 2 numbers. So when you have a positive 6 and combine it with a negative 84, our result is a negative 78. Now we're going to start with our first example. So here we're going to combine the integers. We have 4 different examples in this one. Here we have a negative 15 and a negative 3. Now notice I stressed the word and. Whenever you have a positive symbol or a plus sign right before a set of parentheses, that means and. When we have a negative 15 and a negative 3, according to our rules, we have 2 negative numbers, which means our answer is going to be negative. And then we add the 2 numbers, 15 and 13. Our result is a negative 18. Now let's take a look at what we have here. Now, in the old days, you used to call this 35 minus 6. But remember what I said, I want you to start recognizing these as separate terms. So we are going to start referring to these numbers as a positive 35 and a negative 6. And if you remember from the rules that you just copied, here you recognize that you have different signs. We have a positive number and a negative number. So the first thing we have to do is look and see what our greater looking number is. It's 35, and since 35 is positive, our answer is going to be positive. And our next step is to subtract the 2 numbers. 6 from 35 is 29. So when you combine a positive 35 and a negative 6, you get a positive 29. Let's keep working through. Here we have a negative 7 and a positive 18. First thing we have to do when we're working with numbers that have opposite signs, take the sign of the bigger looking number, and here it's positive because the 18 is bigger looking than 7. Now you subtract the numbers, 7 from 18 give you 11. So when you combine a negative 7 and a positive 18, we have positive 11. And lastly, in part 1, we have a negative 24, and here we have a negative symbol, and in parentheses, a negative 11. Now if you remember up here, I said whenever we have a positive symbol immediately before a set of parentheses, that word means and. Well here, when you have a negative symbol or minus sign right before parentheses, it actually means the opposite of whatever is following it. So the way we need to look at this is a negative 24 and the opposite of the contents of these parentheses. So we're going to rewrite this expression because we have to simplify this part of it. This negative 24 will stay exactly the same. And then we have the opposite of negative 11, that is a positive 11. So now we have two integers with opposite signs. Here the 24 is the greater looking number. Since it is negative, our answer will be negative. Then you subtract the two numbers and we get an answer of 13. So when you combine negative 24 and positive 11, our result is a negative 13. Let's take a look at our second example. Evaluate the expressions when b equals negative 4, c equals a positive 9, and d equals a negative 12. Well, you've done problems like this before. What you're going to do is, after you copy the problem, substitute the values for each of the variables. I'm going to move over here. We're told that c is a positive 9, and d, which is a negative 12. Now we have to remember that to the c we're adding, or we are pairing it with the d. So we have to remember to write the d exactly as it is. Because if we change the negative to a positive just because there's a positive symbol here, then you're completely changing the value of d and making it its opposite. So once you substitute each variable in the exact right way, you remember our rules for combining integers. Here we have a positive 9 and a negative 12. Since 12 is the bigger looking number, we'll use its sign. And now we subtract the two numbers and we get 3. So here, c plus d gives us a negative 3. And we're going to do the same thing here. After you copy this problem, we're going to substitute in the value of d. So this 15 will stay the same, and so will this operational symbol. Just like over here, this plus sign was brought right down, this positive symbol. So we're going to bring down this minus sign too. And now we're going to substitute the d. And oftentimes when your integer is negative, we put that inside parentheses to make sure that we are keeping the sign separate. And just as we did in example 1, this minus sign on the outside of the parentheses means the opposite of this integer. So this 15 is the same. The opposite of a negative 12 is a positive 12, which gives us a final answer of 27. And we have one more. b with a minus 5 minus c plus d. First our b, negative 4. We bring down our negative 5, and now we have the opposite of whatever c is, and d. So just so that you're following, all we've done so far, all I've done was to take each variable and replace it with its exact value. So again, we have a negative 4. This negative 5 got brought down. Now we have a negative c, and our c is a positive 9, which is right here in parentheses, and d, which is a negative 12. So now what we have to do is some simplifying. Let's take a look. We have, let me get a different color now. it's important that you recognize all the separate terms that we're working with, especially because now we have 4 and it's a little hard on the eyes. So we are working with a -4, a -5, the opposite of this +9, which is a -9. Just going to circle that because we're not changing the content, we're not changing this. It's a -9 and a -12. As it turns out, we end up with all negative numbers. When you're adding all the numbers, when all the numbers that you're adding have the same sign, we use that same sign in the answer. So since all these numbers are negative, our answer is negative. And now we just add up all the numbers. 4 plus 5 is 9. 9 plus 9 is 18. 18 plus 12 is 30. So we evaluated this expression to be -30. Let's go on to example 3. Now, example 3 you see is a word problem, but remember what I tell you all the time. Don't get nervous, just remember what we've been doing. I know that you're going to apply these rules of integers to this problem. Now, one thing that might be a little bit daunting about this word problem is that there are words in it that might be unfamiliar to you, but we'll work through that too. Here it is. Your checking account shows an overdraft. The balance is -$43. To avoid fees, you make a deposit of $50. What is your new balance? So you probably don't have a checking account of your own, but sometimes adults will write checks for more money than they have in their account. That's what an overdraft is. So when you have a balance of a -$43, it means the bank is going to probably charge you some fees because you need to have a balance that is 0 or greater. You can't be owing the bank money. So what we have here is, we have a -$43. And when you make a deposit, you are adding money. So you're applying a positive $50. And I'm purposely keeping the dollar signs here to show you that just because we're working with money in this problem doesn't mean any of the rules change. So what are our rules of integers? We have a negative number and a positive number. So we have to look to see which number is bigger, looking, and it's the 50. 50 is a positive number. And now we subtract 43 from 50 is $7. So if you have a balance that is -$43 and you make a deposit of $50, you have a positive balance now of $7. So just a couple of minutes ago I told you not to be concerned or nervous when you have a word problem because you're just taking the skill that you've been doing and applying it to a real life situation. Now, unfortunately, that doesn't apply here. I don't typically do this, but the reason I'm including this example here, even though it doesn't follow the rules of integers, is that oftentimes this kind of problem is presented hand in hand with rules of integers. I don't agree with it. To me, it doesn't belong because the skill is different. It might be confusing, but I need for you to have this in your notes and be able to reference it because you will see this. Regardless of the book that you're using, this has been a mainstay where this kind of problem is paired with rules of integers. We'll get through it though. Let's read it. At dawn, the ambient air temperature was -8°F. By noon, the temperature increased 31 degrees Fahrenheit. How many degrees did the temperature increase? Now, because we've been working with integers, your brain automatically wants to go to the -8 and the +31 and combine them to get a +23. But that would not be reasonable. What we need to do is look at this in terms of a number line with 0 degrees Fahrenheit right in the middle, the way that you would read a thermometer. And so what we're saying is, early this morning, it was -8 degrees Fahrenheit. And now, noontime, it's 31 degrees Fahrenheit. This is my kind of weather. And what we want to know is how much the temperature increased from dawn until noon. So we have to look at it in two different pieces. First, we see that between dawn, when it was -8 degrees, we're going to take a jump to the 0. So we're basically taking the absolute value of each of these temperatures and adding them. And when it jumped from -8 degrees Fahrenheit to 0 degrees, the temperature increased by +8 degrees Fahrenheit. And then the temperature continued to climb until noon, and from there it shot up to 31 degrees Fahrenheit, and the difference between 0 and 31 is an increase of 31 degrees Fahrenheit, which means that from dawn until noon, the temperature increased 39 degrees Fahrenheit.